Okay, we have here today an interesting integral from the UNSW Integration Bee 2024, problem 9. We have the integral of x e to the x over x plus pi to the pi plus 1 dx. Okay, I thought this was really interesting because it seems like it needs to be easy, just noticing there has to be some kind of trick here. Like this is just a constant value in the exponent here, and then we have another constant value. But it's making me think that what we could do is kind of just divide this into the x. Because all this together is very similar to just having like x to the n. So I'm thinking what we can do is just use some algebra and try to combine everything over here in the red together. So what I want to do for that, I'm just going to take this and let's rewrite it. But what I want to do in the numerator is I want to kind of create this pi because I can't divide x plus pi into x with that pi there. So what I'll do is just create it, but I don't want to change it. So I'll subtract off that pi. So here I'm just adding 0, and we have this all multiplied by e to the x. And from here, what I could do is split this into two expressions. We have our x plus pi here, so we'll use that to divide here. And we have this pi, so let me just kind of separate my parentheses this way, right? And then what we can do is distribute in the e to the x and rewrite this. So when we do that, we're gonna end up with two fractions. So let's distribute this in. So for the first one, we're gonna have x plus pi times e to the x all over this thing. And then for the second one, splitting it on the minus sign, we're gonna have just pi times e to the x, and we'll have the same denominator. But then here in the first one, we just have an exponent of 1 here. So what I can do is actually cancel this out with just one of these. So now here we just have x plus pi. And now from here, what I can do is put this back into the integral and just rewrite this thing. So for this first fraction, what I want to do is bring this thing into the numerator. So I'm going to write it as x plus pi to the minus pi, bring it into the numerator times e to the x. And then here we'll bring in this, we get this minus pi. And again, I'm going to bring this into the numerator, so I can write this as x plus pi to the minus pi minus 1, again adjusting the exponent for the numerator, and then we'll have our e to the x here. But then from here, the thing I notice is just looking at this right here, well, we have the derivative of this. If you just take the derivative of this, it's exactly what we have right here, including the minus sign. So what I can do is if I label that f, and I label that f prime, you can kind of see where I'm going with it. Because then the nice thing having e to the x is if I come over here and let's just call this one g, well then the derivative of e to the x is g prime, which we have right over here. So what I'm trying to say here is that this whole thing, everything inside the integral is actually just the product rule. And so let's look at our product rule. If we have f times g and we take the derivative of that, well then the derivative of that's just going to be f prime g plus f g prime. That's what we have here, just in a different order. Now this is an integral, right? So we can integrate both sides on this, but here if we're integrating a derivative, the solution to it's just going to be what's inside here. So the solution is just going to be f g plus c. And so coming back to our integral, we've already figured out what our f and g is. So we have our f here and our g here. And so I can just go right to the solution for this, just copying down. We're going to have this is going to become x plus pi to the minus pi times e to the x. But actually, I'm just going to rewrite this and bring this into the denominator. So for my final solution, we'll just have e to the x over x plus pi to the pi plus c, and that's it. Okay, there you have it. Interesting problem from UNSW 2024. Thanks everyone for watching. Have a good day.